Hey guys, welcome back. Here's your warm-up today. I want you to take a look at it. You're classifying the congruence triangles. Yesterday in class, when I gave you guys that welcome back assignment, the one area where you all had the most questions, where most of you had the most questions was in the triangle congruence area, specifically the HL, the LL, the HA, and the LA. So I want to take a moment today and I want to briefly recover all of the triangle congruences with you and make sure that we can have that building block to go forward. All right, here's your warm-up today. Walk through it, take a moment, pause, work through it, whatever you need to do. All right. So now that you've had that chance, all right, I want to take a look at this first one. So what do we know? We know this side right here for sure is also congruent. Okay, so what we see there is we see a classic side angle side congruency. Right? We have a side right here, an angle right here, and a side here, an angle here, and another side here. And that's what proves those two triangles congruent. Now, this next one's a little bit more difficult, right? But in order for us to easily solve this, we have to realize that this relationship here between these intersecting lines creates a vertical angle there. So now we know that we have a angle, side, angle, and an angle, side, angle, and we can easily classify this as angle, side, angle. Right? This last one, we want to know the missing information on what needs to be congruent in order for these triangles to be congruent. When we're talking about side angle side here, we need to make sure that we're identifying and creating it in a way that explains exactly to us what we need to know. So we need to know angle K and we need to know angle Y, because remember, we have to have that side as a piece of bread, that angle as the sandwich, and another side as a piece of bread. So we'd have to write something like angle K is congruent to angle Y. And that's your answer there. All right. When it comes to this proportion, I'm going to not have a lot of room to do it, but I will get you guys going on it. 6 times K minus 9, because we have to cross multiply, is the equivalent of 4 times, whoops, that's wrong. Let me erase that real quick. All right, we'll start over. We'll go 4 K minus 9 equals 6K plus 1. All right. What we could do is distribute out. All right, we get 4K minus 36 equals 6K plus 6, okay? Next step is to get all of our variable on one side, so we'll subtract 4K from both sides. Negative 36 equals 2K plus 6 minus 6 minus 6. 2K equals a negative 42, divide by 2, K equals a negative 21. All right, so that's how you go through and solve that, and it would be a pretty simple thing for us to do. So again, here's kind of our thing. What you need to know about triangle sums: all triangles equal 180. That's what you guys need to know. Really basic. All right. So our first type of congruency is the side-side congruency. We have three sides in one triangle that are congruent to three sides, three corresponding sides, and a second triangle. Those triangles are said to be congruent. You guys know that one. I'm pretty sure of that one. All right, side angle side, we're creating that sandwich, that sing-songy sandwich, right? Side angle side, side angle side, side angle side, right? And we just kind of make sure that we are reading it in that order to make sure that we're correctly identifying that congruence. So we have one side, one angle, and another second side, all congruent to corresponding parts of a second triangle. Angle side angle is just like that sing-songy sandwich, but we're using angles as bread and the side as the filling. All right, so we're going angle side angle when we have an angle, the side, and another angle. The angle, the side, and another angle. If we were to flip these triangles over, all we have to do is confirm that they are corresponding parts. If we can confirm that they are corresponding parts, it works out. All right. Next one we see the angle side comparison. So that's the non-included side, and we can prove that to be congruent as well. So we have an angle, and a side, angle, and a side. These two triangles can prove to be congruent. This is where it gets a little more tricky because what we're seeing now is we're seeing the right triangles. Now, right triangles are going to have one thing in common. All right triangles are going to have one right angle, right? Really easy for us to identify. The textbook authors, the test authors are all going to put a square there to make sure that you guys know. Now, directly across from that, we have what's known as the hypotenuse, right? In every single right triangle we see, opposite the right angle is going to be the hypotenuse. Okay? This has been proved by Pythagorean and the Pythagorean theorem. It's also been proved to be the longest side because a squared plus b squared equals c squared. Your hypotenuse is your c squared. All right? Now, if you come across a triangle that has two right angles, you don't actually have a triangle. If you come across a triangle that has a right angle and it has a obtuse angle, you also don't have a triangle and you need to get yourself checked out. All right? But if you have two acute angles, that's good. Those acute angles will be down here and up here. Right? Now, outside of that triangle, we have the hypotenuse. On the bottom, we have a leg, and on the other bottom, we have a leg. Those legs are attached to the right angle. They are the pieces that make that right angle, and I hope that helps you understand a little bit. So when they say an HL congruence or a hypotenuse leg congruence, they're telling us that the hypotenuse of each side is congruent to each other, and the leg, one leg on each side. Right? So a hypotenuse leg can kind of be a couple different types of congruences, but the one that would come across the most often would be the ASS congruency, so an angle side side or a side side angle congruency, which is not a typical congruency that is allowed, but because of the hypotenuse leg aspect of it, we can use an HL instead. So you'll never write ASS on your paper, you'll write HL instead. And that's an important distinction to make and an important thing to remember so we can see that. The next type is the hypotenuse angle, where we have a hypotenuse in one of our two acute angles that are congruent to corresponding parts of a second triangle. Right? Now, the right triangle is always going to correspond, so we already have an angle-angle side correspondence. Right? So pretty simple, straightforward to follow there. Next, we see a leg angle congruence. Now, we have one leg, and it doesn't matter which leg, it just has to be a leg and not the hypotenuse that's congruent to it. The same leg in a corresponding triangle, and the two acute angles are corresponding as well. Once that's squared away, we can see that. We can easily decide that this is an angle-angle side, or excuse me, a side-angle-angle. Angle-angle side congruency as well, all right? But it could also be if we erase this, and we move that over to this side here, all right? Now we also have a an angle side angle congruency as well. So there are a couple different ways that you can go about doing that, making that happen. Last one is a leg-leg. The legs are congruent. We're going to automatically have a side angle side congruency because of those right angles there. That's straightforward, eh? All right. So when you guys go and try these, take a moment, look at these. Now that you've had a chance to look at them, hopefully we can identify. So we have an angle, and a shared side, and we have an angle, and a shared side. Now, are they corresponding parts? Well, yeah, if we flip them over and twist them around, we can see that they are. So we know that this is a angle side congruency. Now this one, what about this one? All right, this one we have to remember the relationship there. We have to remember that these are vertical angles, so that therefore they are congruent to each other. So we know that we have an angle side angle relationship. Next up, we have the, a side and a corresponding side, an angle, and another corresponding side. So we know that we have a side angle side relationship. All right, the last one is pretty straightforward. They don't even tell us an angle. They give us three sides. That's easy for us to do. These next ones are a little more complicated because we have to state the reason given. Now, when we look at that first one, they want us to get side, side, side. So we need to be able to identify that these two hypotenuses, or what look like hypotenuses, we don't know if those are actually right triangles, right, are there. So we need to be able to write FD is congruent to PR. Once we do that, we're all set. Again, with that kind of common angle there, they want angle, angle, side, so we need a non-included angle, or can't include the side, so we need to know these two angles here. We need to write that out as angle J needs to be congruent to angle B. Once we do that, we're good to go. So today you guys are going to take a look at these triangles once again and make sure that you guys have this down as we go forward. I want the building blocks to be put in place so that we are ready to move forward. All right, thanks for watching. We'll see you around.